everybody, and thanks for joining me for the presentation today on best practices for virtualizing Hadoop. To give you a quick introduction of myself, I used to work for VMware. I was a Tier 1 specialist focusing on Fortune 200 and global strategic accounts and helping them virtualize their Tier 0 and Tier 1 platforms. In terms of the presentation today, before we get started, I want to give you a brief introduction to myself. I'm from Grand Junction, Colorado. What's kind of unique about Grand Junction, Colorado is it has 4 different environments and ecosystems around it. It's got the Grand Mesa, which is the largest flat-top mountain in the world, east. If you go south, you've got the Colorado National Monument, which is pure red rock mountains. North of Grand Junction, on the top right, are the Book Cliffs, which are pure white rock mountains. And then west of Grand Junction is the desert. So it's a great place to visit. If you come there, give me a call. I'll buy you your first beer there, okay? So today's presentation is going to be a little bit different because what I'm going to tell you today is going to be contradictory to what most of you believe and what most people are going to tell you about virtualization. If somebody brings up the concept of virtualizing Hadoop, what do most people say? Can't do it. There's too much overhead. Now, virtualization used to have a lot of overhead with the older hypervisors, and they typically had anywhere from 10 to 20% overhead. So you could virtualize dev and test, but for high-end production environments, that was just too much overhead to be able to use, right? In today's environments, with the latest versions of the hypervisors, you can get that performance overhead from 6% all the way down to almost near bare metal performance. And I've done that within Wall Street, within the military, within utilities, where if systems go down or don't run fast enough, people lose electricity on the East Coast. So if you make the statement that you cannot virtualize because there's too much overhead, I guarantee you I can prove a lot of scenarios to you where their performance overhead is 6% or less. And there are a number of companies that are getting their performance overhead down to about 2% of bare metal. Looking at some of these numbers, benchmarks, now you understand you got to take everybody's benchmarks with a grain of salt because they're going to cook the hardware to get the numbers that they're looking for. But it doesn't mean that you ignore those benchmarks and not see trends and where things are going. So just a couple points in terms of some recent benchmarks that some people have done is, first of all, they've been able to generate 1 million IOPS with 1 microsecond of latency. Not millisecond, microsecond. In most environments, you can't even measure that. 2, if you look at the size of VMs today, an individual VM can be up to 1 terabyte of memory. It can have up to 36 gigabytes per second of network traffic. You can have up to 1 million IOPS through an individual VM. So obviously, in terms of scalability of creating a VM can handle anything that an individual node would need to have inside of a Hadoop cluster. Now, in this presentation today, I'm not going to go through all the features of virtualization. I'm going to focus more on best practices because most of you could care less if you virtualize and you reduce your CapEx by 60%. You reduce your OpEx by 30%. But I guarantee you there are going to be people in your organizations that do care when you bring in 100 or 1,000 nodes, how much space those servers are taking up, how much electricity, how much cooling, how much heating. And customers are achieving tremendous benefits through the operational efficiencies of virtualization. But today, we're going to focus more on the performance tuning aspects. The one thing that you need to be aware of, virtual servers offer tremendous advantages over physical servers. And they're not just features that are nice to have. They can significantly improve the quality of service that you offer today. They can reduce the downtime that you have on your servers. They can also improve your ability to respond to customers' demands on the fly. What we see the trend is moving to is more and more organizations are going to be offering Hadoop as a service in either public and private clouds. And you've probably seen the recent announcement of Hortonworks working with Rackspace to achieve that. The other thing is I think something that we don't think about as much is when you work with hardware today and you're working with bare metal, operating systems and software for the most part do not have direct access to hardware. They go through software to get there. They go through network drivers. They go through software adapters. So the difference is when you're working with IBM hardware or HP or Dell or whoever, your software is going through vendors, drivers, and adapters to get access to the physical hardware. And you all know that's when you start having problems, because if you can't offer a consistent software stack, there's going to be more bugs that you're going to have to deal with and more downtime anytime you switch hardware. So one of the advantages of virtualization is that you are going to be going through your hypervisor vendors, drivers, and adapters to get access to the hardware, so you can offer a consistent software stack for all of the hardware that you're working with, which by itself will significantly reduce the amount of errors that you're going to have inside of your Hadoop environment. The other thing is, as you see, every year there's more and more companies that are looking for ways to leverage offering cloud services, and you see a number of the cloud providers offering more and more solutions within the cloud. So some of the benefits that I just want to point out that you want to be aware of is if I'm having a server that's having problems and I can't figure out what the problem is, often you can't take it down if it's running your job tracker, your name node, and your master servers, right? So how do you test a system while it's running and try to fix it? Well, basically, I can go out and right-click and do a live clone of that system, where I can even clone it with the same IP address and server name, but I can put it inside of a virtual network, so I have the same exact environment of the live system that's running, and I can test it and figure out and see what's going on. Often when you need to deploy new systems, I don't care what company you've worked on, you'll have some server that's been deployed and you can't figure out what's the matter with it, and you find out, you know what? The golden template that somebody has is not the correct thing as the live image, so there's some network driver patch that wasn't installed. So you spend an hour, a couple hours trying to figure out what the performance problem is, when you can go out and treat your entire stack of the software that you're running, including the operating system, and everything is self-contained in a VM. Working at a VM level gives you a lot more flexibility. So I would highly recommend, before you say, I'm not sure if we want to virtualize, really understand the operational efficiencies that all these features can provide. And then dependent upon the hypervisor that you're working with, will determine which has more features or less. So something that people don't pay as much attention to is when I get calls, customers saying, okay, we're trying to virtualize and the performance overhead is 15%, that's too high. I have found 99% of the time they are not following best practices. So first of all, you have to buy the right hardware, not only from Hadoop, from Red Hat, from a virtualization perspective. If you don't buy the right hardware for the environment that you're running, you're going to have problems with it. So make sure that you have the right foundation for a virtual infrastructure. 2, there are a significant amount of best practices that you must configure and tune for in a virtualized environment, or you are guaranteed to have high overhead. So make sure that you build an enterprise environment from your hardware, from your virtual platform, and your operating system. If you don't do those 3 things, there's no way Hadoop's ever going to run right. So the first natural step to take is leveraging your master servers. You understand that the more reliable the platform is that you're running your master servers on, the more you're going to benefit from it. So your master servers can absolutely leverage all the features of virtualization. So in terms of looking at these best practices, things that you should achieve, and if you can't achieve, then something's wrong with how you configure your environment. So why should you virtualize? You will have less downtime on virtual servers than physical servers. 2, I talked about the reliable software stack. You can offer a higher quality of service. We talked about reducing CapEx and OpEx, and you'll have a lot more operational efficiency by working with virtual servers versus physical. So the first thing you need to understand is you never want to overcommit an SLA or a production environment, and not for the reasons that you think. The second thing is you need to make sure that you have memory locality. If you do not have memory locality inside of NUMA, you are going to introduce overhead inside of your environment. So here's where you need to make sure that you properly configure your VMs to make sure that that's not an issue. Hyper-threading. Now, any best practice I give you, there could be some scenario where you can't leverage that, So obviously everything I'm saying, you need to be testing in your environment. But consistently, customers that turn on hyper-threading for their hypervisors increase their performance by about 20%. Do not set any memory limits on production servers. They are going to create more problems than they're going to solve. And then here I list some additional BIOS options that you want to make sure that you set. When you buy any type of hardware, the BIOS must go through a lot of configuration and tuning changes to properly run a virtual infrastructure. Make sure that you turn on Turbo Boost if the BIOS supports that. Make sure that you disable any hardware devices that you're not working with for that virtual platform. Also make sure that you leave memory scrubbing at the default manufacturer's rate. Be very sensitive to tuning that until you're forced to. That should be one of the last changes that you should make. Also make sure that you configure your OS kernel for either single core or multi-core kernels based upon the number of virtual CPUs that you're working with. And this third bullet is why you don't overcommit a virtual machine for production environments. Is when you get close to reaching the capacity from a memory perspective of a virtual machine, it's going to turn on memory options for overcommitting. It's going to start doing ballooning. It's going to start using transparent page sharing. It's going to start doing memory compression. So when you get close to filling up the memory in a virtual machine, when those options turn on, they will start creating a lot of overhead. So you'd better make sure that you keep your memory within somewhere between 6 to 8% of capacity to make sure that those switches don't turn on. Avoid CPU affinity. Avoid it like the plague. You better have some weird case scenario where you have to turn that on. A lot of people misunderstand CPU affinity. They think if they attach a CPU to a VM, that VM can leverage it and run better. It's actually going to run worse because what it does is it eliminates a lot of the virtualization features that you can use. 2, it ties you to a CPU, but that doesn't prevent other people or other VMs from also using that CPU. So basically, when you attach a VM to a CPU, you actually get less of that CPU instead of more. Sure. Boy, that's a religious question, right? My answer for you is I could care less. The reason being is whatever solution that you're going to use, if you can meet the I/O requirements of the system, then either one is fine. And I've worked with a number of large enterprise companies that have set up NAS, and it's worked great. Other companies won't even consider it. So as long as you can achieve the I/O requirements of that system, you can pick and choose. Did I do a good job of not answering that? Yes. Yes. There are some companies in the U.S. that I've gone out to that are running high-end production environments with NAS and having great success, and they have no plans on moving off of it. So I guess the point is if you do the testing and you see it can meet those I/O requirements, then that's fine. You also have a number of Linux kernel tuning that you have to do, not only within Hadoop, but also for your virtual infrastructures. Make sure that you not only don't have a point of failure based upon your hardware configurations for your master servers, but make sure that within your virtual infrastructure, you don't create single points of failure. Also, make sure that you avoid multi-queue networking. That's going to create a lot of overhead in your environment. Here, we've got a couple points in terms of if you're going to go out and configure larger network environments, because what happens is a lot of people are configuring their slave servers for anywhere from like 24 to 48 gig of memory. But when people start configuring them with 96 and 128, you've got a lot more slots. So if you've got more CPU and more memory that you can drive more work, you'd better make sure that your network cards can handle that level of I/O, and that often becomes a problem when you have those bigger servers. Here are a number of points. You can read these. I'm not going to go through each one of them. But the main thing that I want you to see is there are a lot of tuning things that you have to do to achieve the benefit of performance inside of a virtual infrastructure. In terms of taking a look at storage, dependent upon the hypervisor that you're working with, I put these in here so you could have an example of things that you want to consider from storage, but these are VMware-specific features. Decide if you're going to use VMFS or if you're going to use raw devices. You can pick and choose whichever you want, but make sure that you understand the ramifications. If you use VMFS, you're going to be able to leverage all the features of virtualization that you want. If you choose RDM, you're going to lose some of those virtualization features, but the reason you turn on RDMs is because you want to leverage replication features, snapshot features of your storage vendors. So dependent upon whose features you're trying to leverage will determine if you will use VMFS or RDMs. A lot of people believe that RDMs are a lot faster, and that was true years ago, so they automatically configure for those raw devices, but that is not true today. In all the benchmarking that we did internally when I was at VMware, the performance differences were negligible. So pick one or the other based upon the features that you want to achieve. Also, making sure that you have eager zero thick settings for your VMDKs is a big issue. The other thing is make sure that you have proper block alignment with your storage. That shouldn't be as much of an issue today, but it still occurs at customers, and this will immediately create about 15% of overhead in your I/O if you don't have proper block alignment. I think it's easier to get customers to consider virtualizing their master servers. One, as you move into Hadoop 2.0, it's got a shared disk solution, which puts you into leveraging all the features of virtualization, because virtualization, to really leverage everything, you must have a shared disk solution. I think where people are looking at a little bit more is they're looking at whether they should virtualize their data servers or their data nodes. So what you now have is you have HVE, which allows you to properly have block placement on your data nodes. This has been merged into branch 1 and is currently available in Apache's Hadoop 1.2. What this will do is make sure that you have proper block placement within a virtual infrastructure, because the issue is you understand you have rack awareness inside of a Hadoop cluster, but what happens if you have a physical host, and on that physical host you've got 10 VMs? Well, you want to make sure that you don't have 2 copies of a block of VMs inside of that host, because if that host goes down, you don't want to lose 2 copies, right? So with these extensions, they make Hadoop smart enough to understand that not only may you have rack awareness, but you can also have VM awareness. So it'll make sure that you don't put 2 blocks inside of a host that you have different virtual machines on. And it'll also do the same thing in terms of making good decisions with the balancer, task scheduling, and with your network topology. Giving you some insight into this, you basically work with node groups, and it will make sure that you don't have additional copies of blocks inside of a node group for your virtual machines. So it'll make sure that it is also virtual aware. Now, the thing that's kind of interesting about this that I found a little surprising is one of the concerns that people have about virtualizing Hadoop is losing data locality, correct? A number of the benchmarks that have been run with this, they've actually increased data locality with this configuration instead of having less. The reason being is if you have a virtual machine, have another virtual machine on the same host, and you're running a task tracker on virtual machine 1, but actually the block is associated with virtual machine 2, it can actually use a virtual switch to communicate instead of going through a network card. And if you go through a virtual switch, you're basically achieving communication bus speed performance, which is much faster than going through a network card. So what you can actually do with this is configure one data node in a VM, not have data nodes in the other VMs, and just create task trackers. And then have the task trackers go through virtual switches to get access to the local disks that are part of that host. And if you achieve that, you can increase data locality. Now, a lot of the benchmarks that have been coming out on this are new. This software is new, so I'm not sure that I would want to be the first guinea pig for doing this, but I want you to see that as customers start looking at virtualizing their master servers, some people are going to say, what about virtualizing the data servers? I want you to see that the software is getting smarter, and there are scenarios that where you can trick your configuration into increasing data locality rates dependent upon your environment and the hardware that you're purchasing. So one of the challenges that we have is making sure that we understand how does that block movement work inside of Hadoop. And here, this slide just reiterates that it is smart enough to go out and understand that I'm working in a virtual infrastructure and I could have multiple VMs on the same host, and I need to be aware of that. Now, one of the things that I want to make sure that you do is, instead of having somebody like me have to come out and help you configure your environment, that you do it properly from scratch. If you do this, you don't need to call anybody to come help you. First of all, we talked about making sure that you buy the right hardware. Go through VMware or Microsoft or Red Hat, whoever's hypervisor you're working with. Make sure that you work with their hardware compatibility lists. Then take a look at Hadoop and making sure that you're buying the right hardware with their HCLs. 2, virtualization best practices. There are guides. So I gave you a lot of points just to make sure that you're aware that from a networking, a storage, an operating system, and from a VM perspective, there are very specific parameters you must set if you want to achieve good performance. But these are all out on the web that you can get for free. Make sure you go through those lists and make sure that you're following them. The other thing is, from a storage perspective, 80% of the calls that we got with performance issues and virtual infrastructures were all due to storage, and about 98% of those calls were due to them not following best practices and having their storage properly configured. The other thing is you have a lot more flexibility with virtual machines than you do with physical servers, but basically you also have a lot more rope to hang yourself with. So most companies are not following operational best practices for how to manage virtual machines. You need to make sure in a production environment that you're not overcommitting your virtual machines. That's pretty obvious, right? But when you have these large virtual clusters configured and set up, and all people have to do is right-click to move a virtual machine to a new host, it's very easy for VMs to actually end up in the wrong place and overload hardware and start to get bad performance. So you need to set up management best practices for how you're going to work with that virtual infrastructure if you want to achieve good performance. So all of these things here should eliminate you having to call anybody because you're having performance overhead issues of a virtual infrastructure. They're all out on the web for you to read. If you have problems finding them, you can get my contact information. I'd be more than glad to send them to you. Now, I could go out and list best practices till the sun goes down. But typically when people are looking at virtualizing, they have questions. So I'd like to make sure that I have some time to answer any questions that you have on virtualizing Hadoop, either your master servers or your data servers. Until you use those HVE extensions, you're going to have issues. There's just no way around that. Now, the only thing is I know it's in Apache 1.2. It's currently not in Hortonworks HTTP. I'm not aware that it's in other distributions yet as well. So if you want to virtualize your data servers, you need those HV extensions. Otherwise, you can't guarantee good data locality. I think that one of the choices that we have when we set up a Hadoop environment is who we're going to use to help us manage that environment. If you're a very big VMware shop, I think it's a great solution. But if you're not going to use VMware, then I don't know. I mean, basically it gives you management capabilities, but there's a lot of other software that gives you that management capabilities as well. Basically, it's a hybrid solution. The most mature shops that are doing this, they're using some type of SAN or NAS for their master servers, but they're using local servers for the data nodes. The other thing that I'm seeing companies playing with a lot more, and the ones that are playing with it are achieving good success, is they are overcommitting their VMs in production environments, but they're using flash drives to handle all the swap for that, so they're still making good performance out of that. So a lot of companies are starting to do that and say that they're achieving success. So that allows you to get more out of your hardware. Now, I did say I recommend that you don't virtualize your production VMs, but I would hardcore overcommit your development and test environments. Think about this number. To me, it's mind-boggling. If you look at a customer that's running Hadoop, and you look at all their dev, test, and production systems, typically they have about 11% on average utilization of their CPU and memory. So you look at all the physical servers that they've bought, that they're achieving 11% utilization across all of them. That's like horrible, right? It couldn't be more horrible than that. So one of the benefits of virtualization is to make sure that you leverage the hardware that you've purchased. So you've got to hardcore overcommit your dev and test environment. So as long as performance isn't an issue for any dev and test environment, overcommit the heck out of it. Now, the other thing that drives me crazy is we've been taught that if our CPU utilization gets to 90%, that's bad, correct? If it gets to 95%, it's really bad. That's 100% not true. A CPU is there for what? To be used, right? If you're at 90 or 95% utilization, that means that you're using your hardware. The reason it's dangerous is because I have a hard time getting another physical server or getting more physical memory when I'm using bare metal, right? But if I have a virtual machine, I can add CPU and memory on the fly. So when I'm at 95% CPU or memory utilization, I can do a hot memory add or a hot CPU add and have that system run higher. So in a virtualized environment, you want high CPU utilization. You want high memory utilization. And you let the virtual infrastructure give you the flexibility that you need so you always have the performance that's required. I would say that you should be shooting for and expect to have 5 to 6% overhead overall. Now, another area that people get concerned about is they say, oh, virtualization has too much overhead on the disks. And I know that Hyper-V and KVM are achieving really good performance numbers with the latest versions of their hypervisors. I just don't know what they are off the top of my head. But I do know from a VMware vSphere perspective, with 4.1 of the software, they were able to achieve 5 microseconds of disk latency. With 5.0, they were able to achieve 2 microseconds. And with 5.1, they got it down to 1 microsecond of latency. Now, I'm not saying in your environment you're going to be able to achieve that level, but there are people that are achieving those type of numbers. Now, the one place that was an issue is the fact that if you are going through hundreds of millions of records, that latency can add up, right? If you're working with an OLTP database and you're going out and getting one record from the disk, a block, and loading it into memory, you'll never notice that latency. But if you're going through hundreds of millions of records, that latency can add up, right? But here's what people don't think about. If you're going through hundreds of millions of records, you're not having that latency on one disk. It's spread across all the spinning disks that are in your cluster, right? So it's very hard for that latency to add up to give you bad performance of that, right? So that's also a big misperception that people have. What? Very easy. If I'm an architect or a technologist, or I work with an infrastructure team, it's not coming out of my pocket that the company's having to buy more physical hardware and they're only getting about 11% utilization out of it. It's not coming out of my pocket that they're having to buy more physical space, more cooling, more heating. So they feel, why take the risk? It's just an additional variable that I have to learn about and know about. I don't benefit from it, so stay physical. So the biggest problem that we have, I think, is too many people are saying, I don't want to incur any risk. I want to make sure that I stay physical. And I guarantee you, all the technical infrastructure people, they don't want an additional variable in their environment that they have to deal with. But the problem that you have is if your competitors across the street and you both buy the same amount of hardware and they go virtual and you go physical and you're achieving 11% utilization of your hardware and they're achieving 60% utilization, they essentially have a lot more hardware to work with than you do. If I need to go out and create a new data node and I'm virtualizing, I can go out and right-click and do a live clone, have a prompt come up to change the IP address to the server name, and in about 3 minutes, I have a new virtual machine up and running. Provisioning gives a lot of operational benefits. So that company will outperform you. Now, what's happening out there? Whenever I go to a big customer, they are putting their first clusters physical because they need those first projects to succeed, right? They don't want to incur any additional risk. However, at the same time, every customer I've gone to has brought up the question, can we virtualize Hadoop? And I've asked them, are you going to be virtualizing? And a number of people have said, we're not going to virtualize our first Hadoop cluster. However, for additional clusters that we're going to be creating in some of the business units, they are mandated to virtualize unless they can prove to senior management that technically that cluster cannot be virtualized. So that's starting to occur more and more as well. The other thing is look at where big companies are today. And like I said, I don't know about SMBs because I focus more on Fortune 200 and global strategic accounts. But in most big companies I go to, they are about 70% virtualized. Now, that's mostly their Tier 2 and Tier 3 platforms, right? Over the next couple years, you're going to see them get probably about another 10 to 15% virtualized. And what a lot of companies consider is virtualization as a natural step towards moving towards the cloud and offering Hadoop as a service. So you are going to see more and more companies look at virtualizing Hadoop. Now, is there going to be, all of a sudden, everybody's going to go to 80% virtualizing Hadoop? The answer is absolutely not, right? Just look at the conversations that are occurring at this conference today. However, here's some main things I want you to get out of this presentation. One, if you are looking at virtualizing Hadoop and having a discussion, to say that we can't do it because it's too much overhead, that's not true. Because it's not good for you to say that and for someone to be able to go out and virtualize Hadoop with 5% overhead or less. Now, you may have reasons that you don't want to virtualize, and it could be the fear factor, the comfort level, but don't do it because you say, oh, there's too much overhead, you can't even consider it. Because I guarantee you, you will be proven wrong. The other thing that I think that you should be aware of is, for a lot of companies that we go out and talk to, Hadoop's new with them. They're setting up their first projects. So you understand that it's going to take them some time to get good at managing Hadoop, right? If they have also not set up enterprise virtual infrastructures, well, what this presentation I hope at least showed you is there's a lot of tuning and configuration that you need to perform to have a fast-performing virtual infrastructure. So sometimes taking on Hadoop as a new technology and then taking on virtualization of that Hadoop environment is kind of two big steps to take at the same time. And I would recommend that if Hadoop is new to you, get Hadoop down, get good at it, and then start virtualizing. Yes?
I just want to make sure I understand. When you talk about virtualizing Hadoop, you have the data nodes and you have the other nodes. So
Yes.
primarily talking about the other nodes.
I'm primarily talking about the master servers, yes. It's probably going to be somewhere, I don't know, 6, 8. Because what I'm also talking about is not just your name node or your job tracker node. I'm also talking about any other servers that have software that cluster is dependent upon. The HVE? Yes. And then obviously what you're going to do is you're going to start putting that in a dev environment. Then you're going to move to test. So that way you're comfortable with what the success is going to be before you put that on a critical system. That's correct. I'm seeing very little virtualization of the data nodes today. Very little of that. The other thing that you have is, another benefit is VMware has HA for your master servers, which is a really important feature. Now, whether you want to use Red Hat HA or VMware HA, it completely depends on your personal perspective. And I'll give you my insights, and yours can be different, but I'll just tell you what mine are. Red Hat HA has been around a lot longer. A lot more people know it. A lot more people are comfortable with it. A lot more people are comfortable staying physical, right? But there's also a lot more complexity to managing Red Hat HA. VMware HA, you do 5 clicks, it's set up, and you don't have to worry about it. And what ends up happening is if that virtual machine, the host that a master server is running on, if that goes down, VMware HA will start up that name node or job tracker in just a couple minutes. Because what a lot of people don't think about is when you have a physical failure and that physical server comes back up, it's got to go through all kinds of hardware checks, right? But when you're running in a virtual machine, that's just software. It goes through those hardware checks incredibly fast. So by the time you get an alert that a master server went down, with HA, you're going to get another message that that server's back up. But I don't find most companies deciding whether to use Red Hat HA or VMware HA. They decide if they're going to go physical or they decide if they're going to go virtual. The other thing is I think you really can't underestimate if across, I would bet you that 99 out of 100 companies that we would go visit, across their dev, test, and production nodes, they're achieving probably 11 to 12% utilization of the CPU and memory or less. If you guys just went to 60% utilization of your dev and test, that's like giving companies hundreds of additional servers to work with, right? The other thing that I like is you can create these things called vApps, and every hypervisor vendor, I believe, has some version of that. So what I can do is I can go out and create a cluster that basically has all my master servers, my data nodes, whatever it is, and typically it would be for dev and test. So let's say you had 10 nodes, right? I can configure that cluster to work, and I can put it in a container called a vApp or whatever the hypervisor vendor calls it, and I can go out and right-click, and I can create a new version of that in about 10 minutes, and it will prompt me for the names of IP addresses and servers. So in just a few minutes, not only can I provision a VM, but I can provision an entire cluster. So what do you change in your company if instead of for dev and test, you're achieving 10 or 11% memory utilization and you take that to 50 or 60%? You're now saying, if somebody says, you know what, we'd like to do some more testing, you can spin up other dev and test clusters in a few minutes, let them go through more iterations of whatever they're doing. They're going to generate a better product. Yes? I think that you're going to see in the next year to year and a half, people are going to be wanting to have much more elastic clusters. And I think that once the HVE stuff matures a little bit more, I think that you're going to see people wanting to set up multiple task trackers, VMs per task tracker, and setting up less data nodes and achieving a lot of elasticity out of that. So I expect more, as that matures, you're going to see that happening. They'll spread them around. They'll spread them around. VMware gave the code back to Apache. So I would think over a period of time, you're going to see all the different distributions, make them available over a period of time. No, I do not believe so. I do not believe that. I'm not aware of any other distributions that currently have that in a GA release. Is anybody aware of that? What? Yeah. Oh, yes. Yeah. Other questions? Yes. Yes. Well, hey, thank you very much. I know I went through a lot of the best practices, tips, very fast, but you can get that in the slides. You didn't need those to be read to you, right? And then if you end up pursuing that and you have problems finding those best practices, I'd be more than glad to share them with you, okay? So thank you very much.